Yes, welcome to our new lecture, third lecture, I think. In today's lecture, we are going to cover divisibility, HCF and LCM. Divisibility. These are the tests. In using this test, without doing actual division, we can find out whether the number is divisible or not by given number. Okay, so there are some divisibility tests. Some tests are just by observation we can find out, like divisibility of by 2, divisible by 2, divisible by 5, divisible by 10. These three tests can be used just by observation. You don't have to do anything. Just observe the unit place digit. If unit place digit is even, that means it is sure that the number is divisible by 2. If unit place digit is 5, that means it is sure that it is divisible by 5. And if unit place digit is 0, it is divisible by 2 as well as 5. That is 10. So these three are here. These three tests, we don't have to do anything. Okay. Now let us move to next. Now 3 and 9. In these two tests, we have to just add the digits. And if the sum is divisible by 3, then the number is divisible by 3. If the sum is divisible by 9, then the number is divisible by 9. Okay, let us move to some more tests. These tests are very important actually. You have to learn them properly so that you can easily, without actual doing division, you can easily find out whether the number is divisible or not. And this is important. This is required while doing factorization. We can find factors fast if we know the divisibility test. So the next is of 4, divisibility test of 4. That is last 2 digits. If last 2 digits are divisible by 4, then for any number, if last 2 digits are divisible by 4, the number is divisible by 4. See, for example, I am writing a very big number. You don't have to do division. You don't have to do anything. Just see what are the last 2 digits. 64. Then yes, 64 is divisible by 4. Therefore, this whole number is divisible by 4. Very simple test, right? And then if you know the test of 3 and 4, right? Combinations we'll do afterwards. Then next comes 8. Here, last 3 digits. Okay. Here also, if I write a very big number, 357928808. See here, these are the two last 3 digits. And easily we can say that it is divisible by 8. And therefore, this number is also divisible by 8. Okay. Next comes 11. In this test, you have to consider alternate digits. Find the sum of alternate digits and then find the difference of those two sums. Alternate digits means you will get two sums. Find the difference of those two sums. If that difference is either 0 or multiple of 11, then the number is divisible by 11. Very simple. You can take 5335. Look here. Alternate digits. These are alternate digits. These are 5 plus 3, 8. Then 3 plus 5, 8. And 8 minus 8, 0. And therefore, this number is divisible by 11. Right? So these are the basic, all the tests. Now we'll consider combinations. Let us start from the combinations. 1 minute. Let us do clear. Now let us take combinations. Divisibility of 6, that is 2 and 3. If the number is divisible by 2 and 3, it is divisible by 6. So what we have to see, check the unit place digit, add sum of the digits, you will know whether it is divisible by 6 or not. Similarly, 12, here it is 3 and 4. Check last 2 digits if it is divisible by 4, then go for sum of the digits. Okay, so like this, various combinations are there. 22, here 2 and 11, 15, here 3 and 5. Many combinations are there. So if you know the basic test, we can apply those tests to find out divisibility of other numbers also, like this, right? Okay, so let us start solving sums. Okay, see now, here is our first question. As I have told you in the beginning previous lectures, they are not straightforward questions, slightly tricky questions. See what is here. What should be added to the number 2099 so that it will be divisible by 66? Now look here, 66 divisible by 66. 66 means it should be divisible by 2, it should be divisible by 3 and 11. Right? Okay. So for divisibility of 2, what we need to have, the number is 2099. It is odd number. So first of all, 1 must be added to it so that it will be even and then divisible by 2. And therefore, this number will be 2100. Then divisibility of test, we can just, it is very obvious. 3 sevens are 21 and therefore this is divisible by 2 and 3. So it is divisible by 6. Oh, sorry, 6. Only 6. Okay. Now we want to apply the test of divisibility of 11. Here the number is 2100. 2100. Alternate digits. 2 plus 0, 1 plus 0, no. The difference is 1, which is neither 0 nor multiple of 11. And therefore, this number is not divisible by 11, right? So now what we have to do? To find divisibility by 11 also, or to get the number which is divisible by 11 also, what we have to do? We have to go on adding 6, because it is, this number is divisible by 6. So we don't want to change that. So keep adding 6. First, let us add 6. So what you will get? 2106. So what is the number 2106? See the alternate digits. This is 2, this is 7. Not correct. So this number is also not divisible by 11. Again, go on adding 6. So now it is, yes. Now see this number 2112. Alternate digits. 2 plus 1, 3, 1 plus 2, 3, and now this is divisible by 11. So far, how much, what we have added? We have added 1, 6, 6. So 1 plus 6 plus 6, we have added 13. So if you add 13 to this number, then the number is completely divisible by 66. So what is our answer? C, 13. Okay. We are applying 3 tests over here, 2, 3 and 11. For 2, first we added 1. Immediately we got whatever number we got, that was divisible by 3. And therefore afterwards we proceed with the 6, because now the number has become divisible by 6 and therefore we added 6, right? Because we don't want to change that. Once it is divisible by 6, if you add 6 to it, it is not going to change. And therefore, this is divisible by 6. This is also divisible by 6. And now at this stage, it is divisible by 11. So total we added this much. And therefore, answer is 13. Let us move to next question. How many 4-digit numbers with middle 2-digit 97 are divisible by 44? Divisible by 44 means 4 and 11. Okay, they are saying 4-digit number, 1, 2, 3, 4, and middle 2 digits are fixed, 9 and 7. Okay, so first let us apply divisibility of 4. last two digits should be divisible by 4, right? Okay, so last two, now here we can write any digit here over here, but it should be divisible by 4 and therefore the number should be even, right? So first let us take 70, 72, 74, 76, 78. Here I can write 0, 2, 4, 6, 8. Out of that, which is divisible by 4? Yes, this is divisible by 4. What about this? This is also divisible by 4. And these three are not. So here we get either 2 or 6. So now if I write 2 over here, this last 72 is divisible by 4. And therefore, if I write any digit over here, it is going to be divisible by 4. But what is our next condition? It should be divisible by 11, right? So just add the digits, these two and these two. So 9 plus 2 equal to 11. And therefore 7 plus something equal to 11. So this number must be 4. And therefore here at this place it should be 4. So first number which we got 4972, which is divisible by 4 as well as 11, and therefore it is divisible by 44. Okay, now if we take 6, at this place if we take 6, because 76 is divisible, so I will write 6 over here. Now last 76, it is divisible, and therefore we have to find out this digit. Here I can put any digit. So it will be divisible by 4, but now what we want? 11. So let us add alternate digits. So 9 plus 6 equal to 15, and therefore dash plus 7 equal to 15, and therefore this box is 8. And here it should be 8. So 8 plus 7, 15, 9 plus 6, 15, 15 minus 15, 0, right? And therefore our next number is 8, 9, 7, and 6. And because only these two options are available for divisibility of 4, only 2 numbers can be formed. So how many numbers we can form? Only 2 numbers. So here the option is A. Okay, let us move to next question. Yes, in this question, look here, how many numbers of the form A, B, B, A, means it is a 4-digit number. First and last digit are same and middle 2 digits are same, are there which are divisible by 18, right? The number is in the form A, B, B, A. Okay. It is a 4-digit number, it is given, so A cannot be 0. Okay, and then divisible by 18. Divisible by 18 means divisible by 2 and 9. So divisible by 2 means it should be even number. So A must be even. A is even. And A cannot be 0, so it is 2, 4, 6, and 8. So A can be 2, 4, 6, 8, right? So let us write. And now afterwards it is divisible by. So first let us write this 2BB2. This is first one. Then I will write 4BB4. Then 6BB6 and 8BB8. Now it is divisible by 9. So some of the digits must be divisible by 9. Right? Now here 2 plus 2, 4. So 5 is remaining. It is not possible because it is odd and both the digits are same. So I cannot take 2.5, 2.5. They are not digits. And therefore 9 sum is not possible. Even here it is 4 plus 4, 8. Only 1 is remaining. That is not possible. Because all these digits are even, their sum is even. And therefore the sum of middle 2 digits becomes odd. And that is not possible. Right? And therefore we will go for sum 18. If the sum is 18, then also it is divisible by 9. So for sum 18, 2 plus 2, 4. So 18 minus 4 is 14, and therefore B must be equal to 7. And therefore the first number is 2772. See, sum of the digits, it is even, so divisible by 2, and sum of the digits is 18, so divisible by 9, and therefore the number is divisible by 18. Similarly here, 4 plus 4, 8, and therefore B must be 5, right? 8 plus 5, 5 plus 5, 10, 10 plus 8, 80, and therefore the number is 4, 5, 5, 4. Look here, 5 plus 5, 10, plus 8, 18, and now it is divisible by 9 as well as 2. Now here it is 6 plus 6, 12. 18 minus 12 is 6. So B is equal to 3. I can add over here if you are confused. This is 16, therefore B plus B is equal to 14. And therefore B 7. Similarly here I will write B plus B is equal to 10. So B is equal to 5. Now here it is B plus B is equal to 6, and therefore B is equal to 3, and the number is 6336. Okay. Similarly here 8 plus 8, 16, and therefore B plus B is equal to 2, and therefore B is equal to 1, and the answer is 8118. So these are the four numbers which are divisible by 18, and they are in the form ABBA, 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 ABB. Okay. So the answer is four numbers, that is C. Now the next question. See, number is given is divisible by 8 as well as 11. Then find the value of 2m minus n, where m and n are single digit numbers. Let us see now. Divisible by 8. The number given is m, 5, 3, 4, and n. Divisible by 8, so last three digits should be divisible by 8. So what it should be, let us see. 3, 4, and n. Right? If you divide by 8, what it will be? 8 4s are 32, 2 will remain. Now if I put last two, this is, if n is equal to, I can put any digit, but it should be even because divisible by 8. So first I'll put 0, 2, 4, 6, and 8, right? Then 340, 342, 344, 346, 348. Out of this, which is divisible? Which number is divisible by 8? Look here. 3 8s are, 8. 8 4s are 32, 20 not divisible. 8 4s are 32, 22 not divisible. 8 4s are 32, 24. Yes, this number is divisible. This number is divisible by 8. Again here 8 4s are 32, 26 not divisible. 8 4s are 32, 28 not divisible. So only one number is divisible, and therefore n must be 4. Right? So let us write this number here. M 5, 3, 4, 4. And now alternate digits. Now we have to check for 11, right? N we got. Now let us check this. That is M plus 3 plus 4 equal to 5 plus 4. These alternate digit sum must be same, then only their difference is 0, right? So here it is m plus 7 equal to 9, and therefore m must be 2. Okay, and now let us put the values of m and n in this 2m minus n. It is 2 into 2 minus 4, that is 4 minus 4 equal to 0. And hence our answer is 0, or option is A. What we did here, we tried because it should be divisible by 8, means number must be even. So we tried all these. Out of these 5, we got only one number which is divisible by 8. So n must be 4. And then using 4, we tried the test of 11. And using the test, we got m is equal to 2. And then just put the values of m and n, you will get value 0. Okay.